So in this video, we are going to discuss about OSI reference model. OSI stands for Open System Interconnection. It is a reference model which was developed by International Organization for Standardization, ISO, around in 1980s. Now, the main intention of this OSI model, it's going to define how the communication happens between two or more network devices. It's a layered architecture which contains 7 layers, and each layer is going to define a set of functions. So let us see what exactly this OSI tells. So OSI tells, in simple, it tells how the communication happens between two or more network devices. It provides standardization for how the communication happens. Let's take an example. I'm going to take some general examples, like if you're accessing internet, I'm going to type the URL path of any specific website. Let's say I'm going to access some yahoo.com on internet. So when you try to access, the packet goes to your nearest router. Maybe first it will go to switch, which is an intermediate device, and the switch is going to connect to your router if you are in the production networks, and from the router it's going to power the packet to ISP, and ISP is the one who is connecting to internet. It reaches the internet, which is your biggest network in the world. So internet is a public network where everyone is connected, and from the internet it reaches the Yahoo server, which may be in a different location. So it can be any Yahoo server which is going to respond to your request. The packet reaches the Yahoo server, and the Yahoo server is going to reply back. So your request goes and your reply comes back. So this is the entire process, and this process happens in fraction of milliseconds. So maybe Yahoo server may be in a different location, very far from your location, but still there are a lot of devices involved in this process, and there is an intermediate process also involved, which is going to ensure that your communication is perfect. Okay, so that both the devices can communicate with each other. So here the end user which I'm accessing, it is my source, and the destination is, this is your Yahoo server is my destination. But when it comes to this process, there's a lot of things involved here. So this OSI model is going to define a specific standardization, like if I'm using a router. So router is a device which will do the job of routing, and the router has to work in this method. It has to check the routing table, it has to forward the packet. So more in detail about routing process, we have coming sections. In our routing concepts we'll be discussing, and then there is a switch device which is involved, or maybe you have some hub switches involved here, and internally inside your computer we are also using some web applications. Maybe you are using some Internet Explorer, or maybe Google Chrome, you may be using Mozilla. So so inside that there are some different processes. So these are all internal processes. We can say they are software process, and then there are some specific devices involved in the process. So this OSI model is going to give a detailed understanding on how this process happens, and this entire process is divided into some layers. That's what we discussed just now. It's a layered architecture, and each and every layer, so they divide into 7 layers, and each and every layer is going to define a set of functions. So this entire process is divided into 7 parts, and we call them as layers. We call it as a layered architecture, and each layer is going to define a set of functions. So here in this video we are going to understand that particular purpose, what are those layers, and what is the process happens in each and every layer. So in general, our day-to-day activities, we will see these things. So we are just trying to understand in detail. So the main advantage of this understanding this OSI model, it's a reference model, is the first thing is when you do troubleshooting, we may really use this layered architecture process to figure out where the problem is. In practically, this is the advantage which will give some very good idea on step-by-step process, how it goes. Okay, so probably whenever you are doing some troubleshooting, you can check the router, you can check the layer, what happens here, and you can check the switch, you can check the connectivity like that. So it will give some very good understanding on, especially in the troubleshooting. And globally, in general, the main advantage of OSI is it provides a standardization. So now standardization, which is going to tell router behaves like this, and it provides standardization for any vendor. So let's take an example. I'm going to use my router in my production network. So it doesn't matter which router you're using. Maybe you're using some Cisco router, or it can be Juniper router, or it can be any other brand. But it doesn't matter which router you're using, because all will follow the same standard method of routing process. And in my LAN, maybe I'm connecting some switch, so it doesn't matter. So just like, when you are purchasing a PC, every device is having a standard size of motherboard and a standard size of cards, and the port connectors, whatever we use, everything is standardized. So if it is not standardized, if every vendor started using their own design and sizes, it will not be compatible with other devices. So that is one of the main advantage again we get with the OSI models. OSI model in general defines standardization also on how the devices should communicate with each other. At the same time, it is going to provide a detailed description of how it works. So there are a lot of books on OSI model you may find which use a very in detailed description. So respective with our CCNA examination, we may need to look into some basics of OSI model. What is OSI model, and the advantages when it is developed, something like that. And then we need to understand the layered architecture of OSI, like in which layer what function happens and which devices are involved in that, what is the process happens in each and every layer. So this is something you may be tested in your CCNA certification exams, and also you may also find in the future. So but in practical, this OSI is more in use when we do troubleshooting. So if you have a very good understanding on these OSI models, we really have we can do some good troubleshooting as well, verifying a layer by layer. So let's get started with the first layers. So let's come down to my OSI layers, which I discussed just now. It's a layered architecture which contains 7 layers. In that, these are the layers. Like you can see here, I got some application layer here. So the first layer is physical layer, data link layer, network layer, transport layer, session, presentation, and application layer. So now in these layers, the top 3 layers, generally we refer them as software layers or normal user support layers, which means these layers are generally happening, this process happens generally inside your PC. So inside your application, we can say. Mostly they are application specific process. This process or application specific process, whereas the last 3 layers, you can see it's not last 3, it's actually the first 3 layers. We generally refer them as hardware layers. So why we call them as hardware layers? Because your hardware devices involved here. Like if I say in network layer, there is a device called router which is involved here. And when you talk about data link layer, we have some switches involved here. And when we talk about physical layer, we have some hubs, repeaters, cables are involved here. So whereas here, there are no devices involved, but it's an internal process inside your computer. So inside your application, we can say. So the transport layer is the core layer of the OSI model, which is going to provide interconnect your hardware layers and the software layers. Okay, so we are going to see each and every layer in detail. So now, the first thing, as per your CCN examination, you need to remember this order. That is one important thing. So whenever I say layer 5, means you have to understand it's a session layer, because you may be tested in your examinations, you may be given in options like router works in which layer. So router actually works in a layer 3, it's a layer 3 device. So the options may be in the form of number, or it can be the name of the layer. So you need to really remember this part when it comes to CCN examinations. And also mostly in the theory concepts also, you will refer a router as a layer 3 device. So let's get started with our layer, 7th layer actually. It's application layer, which is responsible for providing an interface for the users to interact with applications or networking services. So let me take one example here to understand my application layer. In general, whenever we are doing some web browsing, so I'm going to take some examples. The examples mostly, the very basic examples, most of the time I'll be using my examples on internet, but I'm not talking only about internet. It can be any network. It can be any WAN network, any company production network, or it can be any LAN network. So it can be a private network or it can be a public network. So whatever the network, mostly all the devices are involved here. But most of the time I'll be using my examples of internet, because when you're starting your basic things, you are a little bit more familiar with some internet examples. So whenever you are trying to access some website, let's say I'm going to access some xyz.com. So if you want to access a website, the first step, you need to initiate this application. Initiate. So initiate this application, nothing but you need to type this URL path on you need to type this path. So where we are going to type, we are not going to type somewhere in our notepad or any other files. We are going to use some web application like web browsing tool. So maybe I'll be using Internet Explorer, or it can be Mozilla, or it can be Google Chrome, it can be Safari. So any browsing program. So now this browsing program is actually an application or a software which is going to allow you to access web pages. Like if you want to access any web pages on the internet, then compulsory you need to use any of the browsing tool. So now generally we say these are the browsing programs which we see, but internally there is a protocol called HTTP which will do the job. So now whenever we type anything, we generally see http:// we'll see www.xyz.com. So this is what your HTTP service. So HTTP is an inbuilt protocol inside your TCP/IP. TCP/IP is a protocol set which we'll be discussing in our next session more in detail about TCP/IP. But there is a protocol called HTTP which is responsible for allowing you to access web pages. Similar way, if you are sending and receiving any files, there is a protocol called FTP, file transfer protocol, which is responsible for sending and receiving the files. Similar way, whenever you are sending and receiving the mails, there are some protocols called SMTP, POP3, IMAP. So if you have done some Microsoft things, you will find in Microsoft Exchange servers, you'll find these different types of protocols which are used, generally referred as mail server protocols. So similar way, if you're accessing any remote device, we are using Telnet, DNS, DHCP. So I'll come to these individual services in my next sessions, where I'll again explain you the basic functionality of this each and every protocol, what exactly they do. But what I mean to say here is application layer is going to provide an interface. So the main job of application layer is to provide an user interface, so that nothing but it is initiating the application, and to initiate the application there should be some interface. Now in general, these browsing programs or browsing tools are providing the interface, but the backend protocol for this is HTTP. We are sending and receiving the files, we are copying the files from the network, we are downloading some files from server on my network, but the backend protocol is FTP. So like that, when you're sending and receiving the mails, maybe I'm using some Gmail, so probably Gmail is my server where my mail server, it's a mail server, but internally backend protocols are SMTP, POP3 and IMAP. So these protocols are actually allowing you to initiate the application. At the same time, they are providing some interface so that you can interact with that specific application. You can access that particular service. So this is the job of application layer. So application layer provides an interface. It's initiate the application, and also it provides a user interface. So that's what you can see here. It is responsible for providing an interface for the users to interact with application services. So general example is a web browser, but the backend protocols. So identification of the service is done based on the port numbers, which means each and every service is identified with a logical port number. So the range of the port numbers are 0 to 65,535 is the range of port numbers. This is the default range of port numbers. In that, again 0 to 1023 we call them as reserved port numbers. And whereas from 1024 to the end, we call them as unreserved port numbers. Unreserved means, like if I take an example, HTTP works on port number 80, which means it comes in reserved port number. Means 80 port number is reserved category. FTP works on port number 21. So like that, each and every service will be identified on a different port numbers. But if you want, I can even host my HTTP service on another port number like 8000 or it can be 7,000, any other number. So to host your services or other than any port number, we have to use this range, unreserved port numbers. So we call them as unreserved port numbers because mostly sometimes you can also do these things, like if you want to access some website, so you can even say the port number also in the end. So 8080 means I'm going to access this web page on not on port number 80, but instead I'm going to use on port number 8080. So this is something you can even do. So it's not our job, it's a job of a server administrator who is going to host your websites, okay, but that is possible. By default all the websites are hosted on port number 80, but still we can change it. Similar way, all the files are transferred, downloaded on port number 21, we can change like that, similar way, but not really required to do that, but just to understand where we generally use this unreserved port numbers. So now the next thing, so that's what I discussed. Identification of the services is done based on the port numbers. A port number is a logical channel. It's not a physical port. There is no physical port we are discussing here. It's a logical port, and they are identified with some reserved, some numbers. We call them as reserved and unreserved port numbers. Now, once application layer provides the interface, the next step is presentation layer. So now presentation layer comes into picture here, where presentation layer is going to define a specific format for the data to be sent. So now let's try to understand what is the job of the presentation layer here. So now once we initiate the application, now presentation layer is going to define a format for your data. It's going to define a format for your data. Now what is exactly format? So let me take one example here. In general, we use some applications here. Let's take an example. On my internet, I'm going to access some normal website. Let's say I'm going to access some public website, www.google.com. So when I type this URL path, generally you'll see you don't need to type http:// it's by default. So we'll see something called http is here, which is going to tell that it's a HTTP service. Now similar way, if I try to access any of the banking websites, like if I say I'm going to say www.xyz.com. So this is your website. Let's say this is your bank. So when you log into your banking website, so now whenever you log into your banking website or any of your PayPal accounts or any other financial transactions, we need to make sure that this financial transaction has to be more secure. So you'll see something like the HTTPS. So now the basic difference between these two is both are HTTP protocols, but this is more secure. So we call it HTTP secure. Why? Because the contents inside your web page will be encrypted format, which means it will be in an unreadable format. Whereas here HTTP means it's a normal clear text format. So now when you're accessing your public websites, you don't really need them to be encrypted, but if you want, you can do it, but not compulsory. But whereas when you're doing some financial transactions, some secure information, we need to make sure that it is secure. So they provide very strong encryption methods to make sure that your information is more secure. So no one can see that information, no one can get that information, whatever it is. Now that's what the difference. There are two different formats. Now your data can go in a clear text, or your data may go in an encrypted text depending upon the type of the service you're using. So it all depends upon the type of the service, like type of the website, similar way type of the service. Now depending upon the application what we are using, based on that service, the format will be decided. Now the format can be in a clear text or it can be encrypted text. It can be in American coding. You know, there is something called ASCII code, American Standard Code for Information Exchange, or it can be European code. So whenever you are sending, so the major functions happens in the presentation layer is it defines in which code your data should go, whether it go in a text. If it is in a text, then it is American code or European code. If you are sending and receiving files, your contents, whatever the information you are sending, it can be in a file format also. It can be in a picture formats. Now in that picture graphics, which format you want to send, or it can be in some other format, like it can be we are sending some voice information. So now in voice, which format you want to send. And if you're sending some video files, there are multiple formats, which format you want to send. Now this format will be decided based on the source and destination applications. So now it all depends upon the application what we are using. So based on the application, you will get that information. Okay. Apart from that, we also have something called encryption decryption, means whether your data should go in an unreadable format or in a clear text, which format you want to send. It all depends upon application. And also compression decompression. So in some of the WAN links, when we discuss some of the WAN links like PPP, HDLC in our next concepts, you may see that PPP supports compression, HDLC do not support compression. So if you want, you can enable that, okay, this feature. So depending upon the type of the links, your data may go in a compressed format or it can be in a normal format. So this is something decided by presentation layer. So in that presentation layer, it will decides which format the data has to be sent, and it depends upon our type of the application we are using or type of the URL in general example which I discussed. So now once the application layer, the 7th layer defines the initiate the process, presentation layer defines the format. So we discussed two layers up to now. In that, the first layer we have seen application layer, which is going to initiate the process, which is going to provide an interface, and presentation layer defines the format for the data. Now coming to our next layer, I can say this is 7, this is 6, this is 5. Session layer is number 5. Now session layer, once we initiate the process, once we define the format, still we did not send. The next step is to make sure that the session is established between the source and destination, which means in my example here, so I'm going to try to send the information from source. This is my source, and my destination. This is my destination. So now I want to make sure that source and destination should communicate with each other. I should be able to send and receive the information. So now to make that possible, we need to make sure that the session is established between them. Like in simple, if I take an example of a normal phone call. So you want to talk to your friend. So now the first step we need to do is, we need to dial the number and make sure that we dial the correct number, and then the receiver will acknowledge, he will lift the phone or he will answer to your call. And once he answers to your call, now we are going to send the information. And once we do that, finally we disconnect the call. Nothing but we are ending the session. The same thing here also happens, similar way. So first, and this session layer is responsible for creating the session, the first step. And the session layer is responsible for maintaining that session once it is established. And also the next session layer is responsible for disconnecting or terminating your sessions. So this is the job of session layer. So session layer will ensure that your session is established, maintained, and terminated at the end. So it deals with the interactions between the applications, between the source and destinations. Now these sessions can be simplex, half duplex, or it can be full duplex. The difference is simplex is just one-way communication, where you can only receive but you cannot send any information. In our daily examples, we watch TV, radio. These are your simplest devices where we can only receive the information. We cannot send them. Now, the communication can be simplex, like only you can download. You cannot upload anything, something like that. Okay. Now, the next thing, half duplex. Half duplex is two-way, but not at the same time. Like your walkie-talkie, walkie-talkie, where you can send the information, and once you send the information, you'll say code word called over. So once you say over means then he will pass on the information. Then you'll say over, and then generally used in military users and in some places you'll find this type of communication. So sometimes you cannot send information both at the same time. And finally, the session can be full duplex also, where both the users can send and receive at the same time. Normal telephone conversations. where you can send the information as well as. So most of the devices nowadays are full duplex. Like initially the switches, I'm not saying only switches. Switches are generally full duplex devices nowadays, and some of the networking devices are half duplex and simplex also. Okay, so no more. So hubs was half duplex devices. Anyway, they don't work in the session layer, but just an example I'm saying here. Okay, so now these three sessions which we discussed just now: application layer, the first one. Application layer initiate the process and also provides an interface. Now presentation layer defines a format for the data, and session layer is going to create the session, maintain the session, and terminate the sessions. So now these three layers, we refer them as software layers or internal layer, because this is something which we cannot see, no hardware device involved. This is happening inside your application. So we're not going to do anything here. Okay, so now the next step, the next layer, we talk about transport layer, which is a layer 4, is majorly responsible for end-to-end transmission of your data. So probably about this transport layer will be continuing in your next part of this OSI. Okay, so check the next video for more in detail about the transport layer and the remaining layers in our second part of OSI model.